Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good morning. So today I'm going to explain about Ipv4 addressing, subnetting and VLSM. Okay, so in this chapter we are going to discuss about, I'm going to give a brief introduction about Ipv4 subnetting. Then I'm going to explain about classless addressing. And then classless inter-domain routing (CIDR) and virtual length, actually variable length subnet mask. Okay, subnetting. As I mentioned before, subnetting is used to divide a network into two or more networks. We have from a large network. Okay, we want to divide it into smaller network, and the network must be contiguous. Okay, so how to in subnetting, some bit we take some bit from the host portion of the IP address and reserve them to define subnet address. So in subnetting, actually what we have done as we know that IP address can be divided into two part, which are two portion. One is net ID and the second portion is host ID. So when we do subnetting, okay, the net ID will remain, but we take some bit from the host portion. We take some bit from the host portion and we change it to become net ID, and that is subnetting. So for example, let's look here. I give you one example. Let's say the first octet we assume that net ID, the rest will be host ID, and this is net, this is host. So when we do subnetting, we take some bit from the host portion, we take some bit from the host portion to become subnet ID, subnet ID. Okay, so that is subnetting. Okay, fewer bit for host, so more subnet. Fewer bit available for defining host. When we reduce the number of bit at host portion, means that we can have more subnet. Each subnet contain less host. That is subnetting. Okay, we increase the number of subnetwork. Okay, when we do subnetting, subnetting implies increase the number of subnetwork, reduce or decrease the number of hosts, and that is subnetting. Okay, now let's look at the first example. We are going to subnet class C address. Okay, so in this class, okay, in this example, consider class C subnet mask address. This is the address, and this is the address that being subnet, and this is the mask that's already being subnet. So this is the subnet mask 255.255.255.190. The default mask of class C should be 255.255.255.0, and that is the default mask. But now it changed to 192, so it's already been subnet. Means that it's already been divided into several network. Okay, so we don't know yet how many subnet that has been done. So we are going to answer this question. We are going to subnet the network address 192.168.10.0. It means that slash. Okay, look at the subnet mask to know how many bit one at the subnet mask. So we have 8, 16, 24. 192 is equal to 1, 1, and this is 128. 128 plus 64 is 192. So 0, 0, 0, 0, 0, 0. And this is 192, and this is equal. Okay, so here we know that 2 bit from the host portion, because the original one is 0, all zeros. the default mask of class C is all zeros for the last octet and the fourth octet. Now it changed to 11. It means that 2 bit from the host portion has been taken, has been borrowed, or has been changed from host ID to net ID. So here 2 bit of the host ID now changed to subnet ID, 2 bit. Okay, 2 bit. 2 bit has been borrowed from host to become net. Okay, so if you want to determine how many subnet, it's over here. The network is divided into how many subnet, so we don't know yet. So we use this information. Okay, we use the bit that been changed from host to ID to determine the number of subnet. So how to get the answer? 2 to the power of how many bit that been changed from host to net? The answer is 2. So equal to 4. So actually the number of subnet now is 4. So from a single network, now when you do subnetting with borrow 2 bit from the host portion, it become 4 subnet. So the answer is 4. How many hosts per subnet? Okay, so if you want to calculate how many hosts per subnet, you need to calculate the number of bits remaining at the host portion. This is the fourth octet, the last octet. Okay, so how many bits? 1, 2, 3, 4, 5, 6. Okay, so if you want to calculate the number of hosts, 2 to the power of 6 bit, and the remaining bit at the host portion minus 2. Why 2? 2 because we need to reserve 1 for network address and broadcast address. So the answer is 2 to the power of 6 is 64, isn't it? 2 to the power of 6 is 64, minus 2 is 62. The answer is 62. So 62 addresses that can be generated, that can be assigned to the host. So how many hosts in this subnet? In total is 64. What are the valid subnet? The valid subnet, so we have subnet 1, subnet 2, subnet 3, subnet 4. The valid subnet means the first address in each subnet. Subnet address here, this is subnet address, and the first address in each subnet. So we have 190.168.10.0/2026. Why 26? Because we have 8 ones here. 8, 16, 24, 25, 26. So /26. Sorry, 26. Okay, what is the second valid subnet? 192.168.10, and the first 3 octet must be the same. Dot here. So what is the next one? The next one should be 60. The total is 64. So 64 64. Over here 64/26. Okay, and then here subnet 3 and subnet 4. What is broadcast? Broadcast is the last address in each subnet. So here for subnet 1, 192.168.10.63. This must be before 64, because the next is 64. So the last address in the first subnet is 63/26. What is the valid host? So the valid host we have in network 1, subnet 2, subnet 3, subnet 4. So for subnet 1, the valid host is from 192.168.10.1 until 192.168.10.62, because 0 is assigned to the network address, 63 is assigned to the broadcast. So in between is the valid address. Okay, so this is the answer. So the same for subnet, 62 hosts per subnet, valid subnet address 0.0.64.128.192. Okay, that is the example of class A. So it will be repeated for class B. So I hope you can watch the next slide. This is for class B. This is the answer for class B. Okay, so we can make it simple by using table to shows the answer of network address. And then what else? This is network address, subnet address. Okay, this is wrong. Okay, the broadcast address and the first host address and the last host address. And this is for class A. Okay, this is the answer for class A. So I think you can have a look. Okay, this is the subnet address, the broadcast address, and the valid host address for the given example. Okay, we are done with subnetting. Now we are going to discuss about VLSM, variable length subnet mask. Okay, in variable length subnet mask or VLSM, actually is a sequence of numbers of variable length. Okay, here is variable length, and I mean the subnet mask slash. Okay, in classful addressing we have /8, for example, /16, /24. Okay, but in VLSM we are considered classless, no class anymore. So we have variable length. We can have slash. This is for VLSM. We can have /29, for example, /30, for example. So variable, make it variable. That streamline packet routing within the subnet of a proprietary network. Okay, a subnet can be a geographically defined local area network. So it will define the local area network. Once a packet has arrived at an organization main gateway with its network number, the packet is routed to its ultimate destination using a subnet number. Okay, the VLSM is usually a string of binary digits shown over the subnet number, telling the router which part of the subnet number to look at. Okay, a binary 1 over a particular digit in the subnet number says pay attention to this digit. Okay, pay attention to this digit mean the slash number /29 /30. So pay attention to this digit. Ignore for digit 0. Okay, /29 mean it will be represented in the form of 1. 1 1 1 1. In total 29 1. Okay, the use of subnet must save a router the task of having to handle the entire IP address, because the router deal with only with the digits selected by the mask. Okay, CIDR, classless inter-domain routing, was introduced to address the issue of rapidly depleting IP address space when classful Ipv4 addressing is used. CIDR uses variable length subnet masking to help conserve address space. VLSM is simply subnetting a subnet. So for example, if you are given a large network, let's say class A network. Okay, class A address. Okay, So this, let's say this is class A, or class okay, any class. So you have a large network. Now you divide the network into several subnetwork, and this using subnetting. Okay, subnetting. Okay, let's say if you subnet class A address, class A, so the subnet still contain huge, has a large size of network, because we know that class A is very large. When you divide into 4 subnet, each subnet still has a large network. So how to divide this large network into smaller network? You can use VLSM. So VLSM can further divide the network into smaller network. Okay, so here you apply the VLSM. So that is the way how we that is the meaning of subnetting a subnet. Okay, this is the slash notation, or CIDR. We use slash notation to identify the subnet, to identify the subnet mask. Okay, now let's look at this example. How we do, how we divide, or how we provide IP address by using VLSM. So we provide IP addressing scheme by using VLSM. Okay, so let's look at the network first. Okay, so we have 3 subnetwork. So we have LAN 1, LAN 2, this is LAN 1, where it contains 4 hosts, LAN 2, where it contains 2 hosts, and LAN 3, where it contains 12 hosts. Okay, so based on this requirement, so you are a network administrator, you are given this address 192.168.1.1/24. okay, so now you are required to provide IP addressing scheme to accommodate this network requirement, which where it has a different size of network. Okay, so first of all, what you are going to do first, you need to remember that the required address, this is important notes, for each network you must consider the number of hosts first, and plus 3 more: network address, broadcast address, and gateway address. So for example, if the network require 5 addresses, so how many address need to be provided here? So you need to don't forget to add 3 more addresses for network address, broadcast, and gateway address. So in total, the required address is 8, and this is the minimum for a network which contain 5 hosts. Okay, so this is an example. So now let's look at this scenario. Okay, first of all, if you want to provide the address, so you need to consider the highest or the largest network, or the network that contain the highest host. Okay, so this is you provide the address hierarchically. Okay, so we start with LAN 3. Why? Because LAN 3 consists of the highest host. Okay, so you put it at the first row. So the first row need to consider LAN 3. Okay, LAN 3 require 12 addresses for the host. But don't forget about network, address, broadcast, and gateway. So you need to add 3 more addresses. So it becomes 15 addresses. Okay, so 15. If you want to provide the address, it must be in terms of 2 to the power of. So the closest to 15 is 16, which is equal to 2 to the power of 5, equal to 15. isn't it? 2 to the power 5 equal to 16. Sorry, 2 to the power of 4 is 8. Sorry, 2 to the power of 3 is 8. Okay, sorry. 2 to the power 4 is 2 to the power 0. 2 to the power of 4. 2 to the power of 4. 2 to the power of 4 is 16. Which is more than enough to accommodate this network. So 16. So we provide 16 addresses. Okay. So how to determine the subnet mask? You can subtract. This 4 means 4 bit at host. Okay. So you can determine the number of bit at net ID. So the number of bit at net ID is 32 minus how many bit at host? 4. So the answer is 28. And this will be the subnet mask /28. Okay. Okay, done. So next, you can identify the subnet address. Subnet address is okay. If you can identify the subnet address and 192.168.1.0/28, and this is the subnet address, the first address in the subnet. Okay. So what is the broadcast? So the broadcast, you need to identify host and network. So 4 bit at host. So 1, 2, 3, 4. Then put the partition 1, 2, 3, 4. This is at the last octet. The last octet. Okay. So 4 bit here, host. Host. And this is net. Okay, network host. Okay. So if you want to determine the network address, host all zeros and net 0, so equal to 0. So over here. If you want to determine the broadcast, okay, here is 0. Host all ones. So this become 15. Okay, over here. /28. /28. Okay, that is the first subnet. Okay, the second subnet, look at the second highest, 2 or 1. Okay, it is 1 because 1 contain more than LAN 2. So put the LAN number LAN 1 because LAN 1 consists of 4 hosts plus 3 equal to 7. 3y3 network address, broadcast address, and gateway. This is the gateway over here. Gateway, and this is gateway. Okay. And the gateway means here the IP over here. The gateway to communicate with. Okay. Okay, now 7 is close to 8, which is 2 to the power of 8 equal to 2 to the power of 3. To the power of 3. Okay, means 3 bit at host portion. Okay. So you need to do the next partition so that only 3 bit will become host. 1, 2, 3, 4, 5, 6, 7, 8. So 3 bit at the host portion. So now host only consists of 3 bit. The rest net. So or equal to if you want to determine the subnet mask, 32 minus 29, minus 3 over here, equal to 29. So slash 29, slash 29. Okay, so if you want to determine the subnet address, okay, you need to know what is the last address in subnet in LAN 3. It is .15, isn't it? So the first subnet must be at the first address after this, and the next address must be 16. So that's why we got 16 over here. 16 should be like this, 0, 0, 0, 0, 1, 0, 0, 0. This is slash, this is dot 16. 16. Hang on a minute. No. Hang on a minute. This is 15. 15 is this is 15. 16 is over here. This is wrong. Okay, so it's supposed to be 1, 0, 1, 1. 0, 0, 0. Okay, this is 16, equal to 16, like this, because this is 2 to the power of 2 to the power 4, 2 to the power 5, 2 to the power of 0, 2 to the power of 1, 2 to the 3, 2 to the power of 4, 2 to the power of 4 equal to 16. Okay, so the first address in subnet in LAN 1 is .16 slash 29. So what is the last address? The last address is 0, 0, 0, 1, 0. This must be remain the same, because they are in the same network. Net must be the same. This is net. Only 3 bit at host portion. Why 3? As we calculate over here, because we want to have maximum 8 addresses. So only host can be changed to 1. 1, 1, 1. So this is what in decimal? This is 16 plus 7, 7. So 23. So the answer is 23 slash 29. Okay, and then the last net subnet, which is LAN 2, and require 2 address for host plus 3 equal to 5. 5 close to 8. It's not close to 4, because if you are given 4, it's not enough. Because you require 5. So you must provide more than 5. The closest one is 8. Okay, so 8 means 3 bit, the same. 3 bit. 2 to the power of 3 equal to 8. So 3 bit will be at the host portion. So it is the same. 3 bit. 2, 2, 4, 6, 8. Okay, so the same partition. 3 bit at the host portion. Okay, so identify the first address in this subnet. Just look at the last address in the previous subnet is 23. So it must be 24 slash 29. The same, because only 3 bit. 3 bit. So 32 minus 3 bit equal to 29. So it is slash 29. So the first is 24. So what is the last address? Okay, so 24. So it should be like this. 0, 0, 0, 1, 1, host 0. Because this is subnet address. And this, if you convert, equal to 24. Where 16 plus 8, 24. So the answer is over here. Okay, so if you want to identify the broadcast, the last address, so 0, 0, 0, 1, 1, host all 1. So this become 31. So if you convert this in decimal, the answer is 31/29. So that's all. How we provide the IP addressing scheme for a given subnet requirement with different size of subnetwork, different number of hosts in each subnet. So this is the way we use a table to show the IP addressing schema. So here the usable address is in between, in between subnet address and broadcast address. So I think that's all for this chapter. I hope you could get the idea of what is subnetting, what is VLSM. So subnetting is used to divide a classful address. For example, class A divide into several smaller class. So VLSM is used to subnetting a subnet. So you already subnet the address, then you want to divide further. So you can use VLSM to divide further the subnet into smaller network. Okay, that's all for this chapter. Thank you very much, and Assalamualaikum.